Hello and welcome to part 6 of Dev Maths and Statistics Refresher Course, Lecture 10. Now we'll carry on with Starter and we'll look at some tests that are a bit more powerful because they have two samples to show what you can do with those. So to save a bit of time, I already, here's one thing we do use the command for sometimes. So I've saved this already. So this is the data. If I go to the browser, you'll recognise it. Yeah. So this is the data that I got from my sample in reading and rice. So that's from here. Oh gosh, a bit of a lag on the system, sorry. Too many things open. So I've just taken this data here. So the gender of head of household, literacy, yield in 1975, yield in 2005, and just show you how you can do some analysis of that. So it's in the data editor. One problem with this at the moment is that this data here is, see, it's string data, so it's just in there as letters, which can make it quite difficult to process, and also it's a dangerous way to have the data because if any of these males or females are misspelled, or the yes or no's are misspelled, or have a capital F or something, that'll be left out, or really muck up your graph. So it's good to get it out of this form. So you can do that with this encode command quite quickly. If I can remember the name of the variable, it was household. Yeah, household 6, exactly. Let's just call it sex, but much shorter. So encode household sex. I put the ST on there to remind myself that that's just string variable in letters. I'll show you how I want it to be in a minute. And then a similar thing. Oops. Household literacy. And generate a variable called lit for literacy. Okay. So far you can't see it's done anything, but if we have a quick look, we'll see what it's done, hopefully. So it's duplicated the variables, but they're not actually the same because these red ones are string variables. Now these blue ones here are long, it's a whole number of variables. So you see where it says male, in actual fact that contains the number 2, female contains the number 1. So it's automatically coded the categories, which is so useful. It's pains to in Excel, and SAS does it really well. It just kind of codes the variables, but then it doesn't show you the noughts and ones here. It puts what's called a value label onto it, and the value label's got these two, so it knows that one is no and 2 is yes and so on. And that makes it easier to process things. Okay, so now we've got that in there, we can use these 4 variables and forget about those 2. So we use these 4 variables to do a similar kind of analysis before. So what we want to know is, when we looked at the summary statistics, it looked as though the women, I'm sure we can do it, can't we? If we summarise the values for the yield, I know you've seen that, let's not go through it again. We've seen it in Excel that in the sample, the mean for women's yield was lower in 1975 and in 2005 compared to the men in both years in my sample. So we wanted to know which of those 2 years in the population can we be confident there's a difference, and it only works with one of them. So what we want to do is a 2 sample t-test. So we're going to test the yield in 1975. So if you press tab, it gives you everything that starts with yield. So I want 1975. So I'll look at the old one first. Oh. And I'm going to do it by sex. Yeah. So previously in the previous example with coffee, I just say test coffee, is it equal to 233? But this time I don't need to have any figure in mind like 233. I just put the comma for the options, and the by command just tests the values of the sets against each other, the ones. So now this is the answer. This is the results you get from the 2-sample t-test. So now it's, because I put bisect there, it's split it automatically into the male and female. So you've got how many males and females there were. You've got the means and standard error for each of them. So the mean is the mean for the sample. So that's what I got when I first did my analysis in Excel. And it looks as though the males are doing much better in 1975, but that could be just random variation. So down here we've got the null hypothesis, which is that the mean of the females minus the mean of the males, the null hypothesis, is equal to 0. In other words, the null hypothesis is that in 1975, in the population, the mean was 0. So if that was the case, what's the chance of getting as far from 0 as this? And the answer just comes out here, 0.0000. This is confusing when people first see it. This basically means it's gone off the scale. So it's less than 0.0005. So it's extremely tiny. It's 1 in 10,000 or something. So it's incredibly surprising. If this null hypothesis is true, getting this is incredibly surprising. So we can be very confident that back in 1975, in the population, there was definitely a difference between males and females. Another way of looking at the same thing is to look at the confidence intervals it gives you. It says 95% confident that the women's mean was between here and here, and the men's mean was between here and here in the population, and there's nowhere near an overlap there. So again, it confirms that we can be really confident we can reject at 99.9% significance level that the means were the same in favour of the idea they were different. So that's fairly conclusive from there. And then, of course, if you click on this command, bring it up again, you can look at 2005. Like so. And yes, go to 2005. Means were different. So again, in the sample, males were ahead. Gives you the other things that you need to calculate the t-test, and the t-value and so on. But this time, the null hypothesis in the population, the males and the female mean is the same. If they are the same, the chance of getting a difference this big in the sample is 50–60%. So it's not at all surprising. So this is telling me it could very easily happen that in the population in 2005, men and women are doing exactly the same. And if that was true, the chance of choosing a sample this size, 5 females, 31 males, and finding a difference as big as this, which was a difference of 19, is very high. So I definitely am not very surprised. I definitely would not reject the null hypothesis. So there's no evidence there at all that men and women are doing differently in 2005. Looking at the confidence interval, the story is the same. There's a huge overlap in the confidence intervals. So that definitely confirms the early analysis that there was no connection between those things. You can extend this. You could do the t-test that we just done. You can look at we only got it in 2005. In 2005, as well as sex, we got this data on literacy. So what does this mean? Just pause the video and see what have I done there. What are the conclusions? Okay, hopefully you paused the video and you went through it. You worked out. I'm just seeing if there's any difference in the yield in 2005 according to whether or not the person is literate. Seems again there's a bit of a difference in the means of the sample, but taking the null hypothesis of no, again the probability is really high. So it's not at all surprising. I would not reject it. Confidence intervals overlap, so there's no evidence there of any difference. So the only one we get a significant difference is here when we're looking at the differences between males and females in 1975. Okay, so that's t-tests, and hopefully you can think of many examples of using 2-sample t-tests to test all kinds of differences between groups. Really, really helpful sort of Swiss Army knife of tests. But just to mention one other test, the chi-squared test. I've got two variables in here, sex and literacy, which they're both nominal or categorical variables. So it'd be nice if I could see, as I try to ask you, is there any evidence of any association between the variable, whether you're male or female, whether you're literate or literate? So a good test that can do that is the chi-square test. So if we try and do that, it's kind of built into tabs are a command which lets you do all sorts of tabulations and tables. But which way around does I want this? I did sex by literacy, came out more clearly. So row percentages and expected values. And then you type in chi squared, meaning chi squared. Yeah, okay, and that does two things at once. It gives you this tabulation. So here you've got sex here and literacy, no yes here. And it's percentages across the rows. It said among the females, not literate is 40%, literate is 60%. Among the males, not literate is 19%, literate is 80%. So it's higher among the males, as I said. But the question is, what's this telling me about the population? So what do you think the null hypothesis would be in the population? Think about it. And the null hypothesis in the population would be that in the whole population, there is no association. There is no relationship. So if I got everybody in the population and graph and put it on this table, I'd get the same percentage breakdown along here. And if I did the percentage breakdown this way, I'd get the same for yes and no, and the same for male and female. So I can see that in this sample, I haven't got it, but is this sample far enough away from an even breakdown? I mean, that's quite extreme. Can I say, okay, in the population, that's strong evidence? Well, the way that this worked out is to calculate these other strange variables, which are called expected values. And this is done by saying, okay, let's take the let's work. If you take the no and yes literacy, overall we've got 22.2% and 77.8% is the no and yes. Let's apply those percentages to the total number of men and women. So to the 5 females, let's put 22% here and 77% here instead of 40 and 60. And same for the 31 males. Let's split them up according to these percentages. So the percentages are even across this way. The calculation actually works out as you're going to do the 22. It's this 5 divided by 100 times 22. So it's this times the 5 divided by the total of 100 people. So it's a sample of 100. No. Sorry, no, it's not. It's this 8 times the 5 divided by 36. Sorry, to get the right percentage. Yeah. And then 28 times the 31 divided by 36 will give you the expected value here. So if there was no pattern, if the percentage was the same in both groups, then you'd have here these observations. So you can see you've got more females than you expect in the literacy here. Sorry, fewer than you expect, 3 compared to 3.9, and slightly more males than you expect literate. But is this close enough? And you can show mathematically that these differences, if you square them, add them, follow the chi-squared distribution. So idea of squaring and adding normal distribution, so you get a chi-squared. So if you total up the differences squared and normalise them, you get a statistic which follows the chi-squared distribution. You look this one up, and the probability comes out as 0.03. So when you do this, you don't have to follow any of the details of the calculation. You just do the crosstab, read this off here, and even though it's based on a completely different test, you interpret it in the same way. So null hypothesis is no connection in the population. This is the connection I've got, which has got a chi-square value of this. The probability of seeing that strong connection, if my hypothesis is true, is 30%. So would I reject the idea there's no connection in the population? Because if that idea is correct, the chance of seeing data like this is 30%. So does that mean I reject the null hypothesis? And the answer is no, I don't, because it's not at all unlikely. So this information here isn't enough to make us reject the idea that literacy and sex in the population is not connected. So there's no evidence of any relationship between the sex of the head of household and whether or not he or she is literate. So that's this chi-square test, which again is a really handy one anytime you've got two lots of categorical data and you want to know whether they're associated, like sort of sex and occupation or religion and migration status or whatever. It could all be done with a chi-square test. Okay, so hopefully in the live session there'll be time to go through a few more examples of tests, and I hope that you enjoy using Stata for this session and all through the rest of the year. But for now, thanks for watching.